Hey guys, I'm going to go through answers on the practice test real quick, just in case you need some explanation. So first one, 95% will be between 30,000 and 36,000. That is true because in the very first lesson of the chapter, you'll notice that 30,000 would be 2 standard deviations below the mean. 36,000 would be 2 standard deviations above the mean. So one of the rules was that 95% would be within 2 standard deviations of the mean. So that is true. Similar issue going on here. 68% would be within 1 standard deviation of the mean. So this is 1 standard deviation below. This is 1 standard deviation above the mean. So overall, we are looking at 68% within 1 standard deviation of the mean. So what percent of tires would have less than 31,000? So let's go to the calculator. So I'm going to go to normal distribution, since it's asking me for a percent. And so if it says exceeding 31,000, in other words, greater than 31,000, so 31,000 is my lower bound. Infinity is going to be my upper bound. I'm putting in a mean of 33,000, putting in a standard deviation of 1,500. So here's what it looks like. And I'm going to hit enter all the way down. And we have 90.9%. Make sure that you do round accurately to 3 sig figs. So that's where that came from. Now we have the expected number question, so they're going to purchase 3,000 tires, which means we have to find the percent and then multiply our percent times 3,000. So how many would last less than 29,000? So that means I'm going back into distribution, normal distribution. Less than 29,000 means I'm going from negative infinity up to 29,000. My mean and my standard deviation are not going to change for this. So here's what I'm putting into my calculator. So this gives me a percent, a very small percent, less than 1%. And we now have to apply that to the 3,000 tires that we are buying. So we're going to multiply that times 3,000. So I'm not even going to change that number. I'm just going to hit times 3,000. And we would round that to 11.5 if we're going to go to 3 sig figs. Guys, really important that when you take your test that you use exact answers all the way through until you get to the very final answer. That's when you can round it to 3 sig figs. So that's where we get the 11.5. Bottom 18%. So as soon as I recognize they're giving me a percent, this is now an inverse normal question. And remember, I always want the left side percent. This one is already giving me the bottom 18% or the left 18%. So I know that's the number I'm going to use. So I'm going to go to my inverse normal. And I'm putting in an area of 18%, so 0.18. My mean is still 33,000. Standard deviation is 1,500. So here's what's going into my calculator. There we go. And so again, we're being asked to round everything to 3 sig figs. So 31600. So there we go. Let's go on to the next one. All right, so means 13. We got standard deviation is 2 days. So what percent lasts between 11 and 16? So this is where they're giving me a lower boundary and an upper boundary, and I'm going to get the normal distribution percent from there. So I'm going to go into my distribution function. My lower boundary is 11. My upper is 16. I'm putting in 13 for the mean and 2 for the standard deviation. So here's what that looks like. And so again, as a percent, and we want to round accurately, that 5 does push the 4 up. So 77.5% if we round accurately. top 8%, again, I see they're giving me a percent, which means I'm thinking inverse normal distribution. Remember, we always want the bottom percent, or we would say the percent left of X. So the top 8% means I need to look at the bottom 92% as I do my inverse normal calculation. So I'm going to go into my inverse normal. I'm putting in an area of 92%. My mean is 13. My standard deviation is 2. So here's what it looks like in the calculator. And guys, this is super important. I'm going to even sketch this one because I want you to see it. But here's what we're looking at. So about 15.8 is going to be our answer. So guys, again, here's something we talked about within the lessons. But if in our bell curve, if I am looking at some unknown x-axis value and they are giving me the top 8%, right? This is the picture that they're painting for us. So we need to recognize that when we calculate this, whether it's in Desmos or in a graphing calculator, when they ask you for the percent or the area under the curve, they are always wanting what's on this side of X, right? That's what goes into the calculator function. So if there is 8% to the right of X, that must mean that there is 92% to the left. No matter which way I say it, it's still referring to the same X value, right? I can say there's 8% to the right of it, or I could say there's 92% to the left of it. No matter which way I say that, that still doesn't change his position. That's still the same X value. But when we calculate this, the calculator always wants this number to the left of X. So that's why we're using that guy. So that's where we got this value right here. So what percent lasts 10 days or less? Again, that's just a normal distribution question, 10 days or less. So I'm going to go into my distribution, go to normal CDF. I'm going to go from negative infinity to 10, because that's what they are describing. My mean is still 13. My standard deviation is 2. So here's what it looks like in the calculator. So 10 days or less. And again, we want to round this accurately to 3 sig figs. So decimal's going right here, so 6.68. That's where we're getting that answer. So now we have the expected number question. So I need to get the percent, multiply it by 450. So if we said after 14 days, right, that means 14 days or more. So I'm going to go from 14 to positive infinity to get my percent. So I'm going to normal distribution, 14 days, and I'm going towards infinity. My mean is still 13 and standard deviation is still 2. So here's what it looks like in the calculator. So from this, we are getting the percent. Now we have to multiply that percent times our sample size. So in this case, we were talking about 450 products. So I have to multiply my percent times 450 in order to get the expected number. So if we round this accurately to 3 sig figs, I'm looking at 139. So that's where that came from. All right. So talking about this this line waiting for tickets. So the average is 21, standard deviation is 3. So what percent is greater than 26? So again, I'm going into normal distribution. So when it says greater than 26, I'm going to go from 26 towards infinity. My mean is 21. My standard deviation is 3. Here's what it looks like in the calculator. So we are going to get about 4.78% if we round that accurately. So that's where that one's coming from. Here's the expected number question. So again, you want to get the percent first and then multiply it times 2,000, which is our sample size. So less than 16 minutes means I'm going to go to normal distribution. And I'm going from negative infinity all the way up to 16 minutes. Keeping the same mean of 21, standard deviation is 3. So if I calculate that, I am now getting the percent. But again, I now need to multiply that by my sample size. So since there were 2,000 ticket buyers, I need to multiply my percent times 2,000. So that's how many ticket buyers, 95.6 is where we're getting this. And guys, totally understand that you're not going to have 0.6 people. However, in statistics, as we look at these things, it's okay to get decimals even when we're talking about discrete data like people, right? So now when they say the bottom 25%, again, they've given me a percent, so I want to use my inverse normal function. I always want the percent to the left of x, and in this case, that's what they are giving me because it says the bottom 25%. So I'm going to go into inverse normal. I have my bottom area of 25%. My mean is 21. Standard deviation is 3. So here's what it looks like in the calculator. And we're looking at, now here's a tricky one. You got to make sure you round this accurately. I do want 3 sig figs. That 7 is going to push my 9 up. So I need to round this accurately as 19.0 if we round this accurately, right? So I do need to include the 0 because otherwise it would not be 3 sig figs. So let's go on to this guy. So on a recent math test, the mean, the average was 78. Standard deviation was 70. Mike got a 90, so where does that put him compared to the rest of his class? There's actually a couple different ways you could do this. I'll show you the way that I approached it. Was he in the top 10%? Well, I took the sort of the path of saying, well, what would be the top 10%, right? So if I did my inverse normal function, and I'm going to show it to you this way. So I'm going to go into inverse normal. And remember, this is talking about the top 10%, which means if there is 10% to the right of x, I want to figure out what is the area to the left of x. And so if there's 10% to the right, I need to put in the lower 90% for my area. Okay, so if there's 10% to the right, that means there's 90% to the left. That's the value I'm trying to figure out. So it looks something like this. In other words, I'm trying to figure out what score would put you into the top 10%. Well, so here's the top 10%. So when I calculate this, this is what I'm putting in, right? Because that's what our calculator needs to see. Whether I say the bottom 90% or the top 10% still refers to the same x value, right? So I need to know what score separates the top 10 from the bottom 90%. So we need this score right here. So they said the average was 78 and the standard deviation was 7. So this is what we're putting in. So in other words, the score that separates the top 10% from the bottom 90 would be an 86.97 score. Right? That's the score that I would need to get in order to reach the top 10%. Well, what did Mike get? We see that Mike scored a 90. So as I look at our graph here, this is what was needed to make the top 10. He scored a 90, which means he scored higher than this. So yes, he did reach the top 10% of his class. All right, let's go to the last one here. So some Oreo cookies. We have a mean of 38. Standard deviation is 3. So here's our expected number question. 5,000 cookies were produced. So how many are within 2 standard deviations of the mean? So there's 2 different ways you could do this. If you base it off of the very first lesson that we did on this, we know that 2 standard deviations of the mean is about 95% of our data. So one way to do this would be to just simply say, well, what's 95% of 5,000? So if I just took 95% of 5,000, that would tell me I'm going to get about that many cookies are within 2 standard deviations of the mean. So that would be an accepted answer. The other approach in order to get this answer would be more of a calculator version. When we do this one, we're using 95%, which is a bit general, as we already looked at in the very first lesson. So you could have said, well, if I wanted to do within 2 standard deviations of the mean, that means I'm going to go 6 above this and 6 below this in my calculator. So I'm going to go to distribution, normal CDF. So my lower bound would be 32. That would be 6 grams below the mean. My upper boundary would be 44. That would be 6 grams above the mean. My mean is 38. My standard deviation is 3. So here's what that looks like in the calculator. So you'll notice this is close to 95%, but it's a little different and it's actually more accurate. So now I could take that percent and multiply it by my 5,000 cookies. And if I round that to 3 sig figs, I'm looking at 4770. Is a more accurate answer, but we would take either one. All right, here comes the last 2 questions, and then I'm done.
Go fast.
I'm going, buddy. Hold on. So cookies are rejected if they weigh less than 34 grams. So what percent would we expect to get rejected? So less than 34 means I'm going to go into my distribution. I'm going to go from negative infinity all the way to 34. My mean is still 38. Standard deviation is still 3. So here's what it looks like in the calculator. And so if we round this accurately, we're going to say 9.12%. All right, how many grams to make the top 15% heaviest cookies? Again, I recognize that they're giving me a percent, which means I want to use an inverse normal setup. So I'm going to do an inverse normal. And again, if they're describing the top 15%, remember we want the number that is below X, not above it. So in other words, if I have 15% above X, that means there must be 85% below X. And so when I calculate this, I'm going to go into inverse normal. And I'm going to use an area of 85%. My mean is 38. My standard deviation is 3. So here's what this looks like in the calculator. So I'm getting 41.1 grams. And that's what I'm putting right here on the sheet. It looks like there was an error there previously, but I've changed that. So this is what it would have to weigh to make the top 15%.